Okay, the last example of 7.4 has an improper fraction, which none of the other examples had. Okay, the way I can tell this is an improper fraction is the degree of the numerator is higher than the degree of the denominator. Just like if you had a fraction with numbers 11 over 5, since the numerator is higher than the denominator, it makes it an improper fraction. Okay, so before I even start the decomposition, I have to first divide to see what's left to make into a partial fraction decomposition. So I'm going to do long division. And I'm going to put a 0 for the missing term, the x cubed, so that my terms line up when I am subtracting. Okay, let's see. This is x cubed. This is 2x to the fourth. To get to, what do I multiply this by? To get this, I multiply by 2x. 2x times x to the third, 2x to the fourth, plus 8x squared. Okay, do make sure you subtract when you're going down. So if I subtract 2x to the fourth minus 2x to the fourth, they cancel. 0x cubed is nothing. So 11x squared minus 8x squared is going to be 3x squared. And then I'm going to go ahead and bring down the plus 4x and the plus 4. Okay, now if I kept going, let's look at it real quick. What do I multiply x cubed by to get 3x squared? This is too high a degree, so actually it doesn't keep going. You could write it as 2x or 2x plus 0, but my long division step is done. Okay, I'm going to rewrite this as a mixed fraction. So when I divided, I got 2x plus my remainder is 3x squared plus 4x plus 4 over x cubed plus 4x. Okay, the remainder is the part that I'm going to make into a partial fraction. So this is the part that I'm going to break down. When I rewrite it at the end, though, I'm going to make sure I include the 2x that I divided out. Okay, but for the sake of the partial fraction, we're just going to start with the remainder. Okay, now if I factor, I can take out the x, and then it does not factor more because x squared plus 4 has imaginary roots. So when I rewrite this for the factor x, that would be a over x plus x squared plus 4. Since this is a quadratic denominator, I'm going to have bx plus c for my numerator, and then I'm going to go ahead and solve for the constants just like we were doing before. If I multiply by x times x squared plus 4. Okay, the x cancels, and I'm left with x squared plus 4 plus the x squared plus 4 cancels, but I still have that extra x. And make sure you distribute it because the mistakes that happen are normally at the simplifying part, actually. Okay, x squared plus 4a. Okay, let me match up the like terms. Okay, so this one's not that bad. I get a equals 1. I have that c equals 4, and then a plus b equals 3. So 1 plus b equals 3. So b is 2. And you do sometimes get a 0 for maybe the b or the c on a problem like this, and that's okay. So don't panic if that happens. Okay, now the only thing to be careful of when I write my final answer, remember this is a mixed number, so I have to keep the 2x from the original division problem plus, and then I have a over x plus bx plus c over x squared plus 4. And then this is the complete decomposition of the original fraction.